Sorry. So we are back in the story problem unit for vertexes or quadratics in the vertex form. So again, this is the stuff we did in that last unit. We did all of that stuff calculating by hand. But this unit we get to use Desmos, so we're going to use Desmos as opposed to doing all of it by hand. We're going to go over examples 1 and 3 in this video, and you'll have to do 2 on your own. All right. So let's start off. You want to dive down to the bottom of the lake to retrieve your sunglasses from the platform. You don't have diving equipment, but you can hold your breath for 10 minutes. If your dive can be described by the following function, so this will be our equation that we're going to use, where dt, and it says d, but this is the only part you see d, so that's dt, so that's our y, is the depth in feet, and t, that little one here, represents our time in minutes. So usually our x-axis, if there's time, it usually is that one. So when we do this, again, we're kind of diving, so I'm going to move the y-axis. We'll probably look at stuff that goes below the y-axis as opposed to above it, because we're going to dive down deep. This will be our water level, basically. And then let's go ahead and kind of label this. The y, remember, is our dt, and he's our depth in feet. We'll write feet for this, so we know every time we answer anything that has the y values, we're going to use feet. And then our x value is technically t, and he represents minutes. So I'm going to put minutes here so that I know that everything I answer will be in minutes. And now I'm going to go over to Desmos, and let's go ahead and get this graphed. So plugging in our equation, that is 1/4 parentheses, whoops, parentheses. Now it says t. Remember, we need to switch it back to x because this is a computer. Computers do not do story problems. They just give us the graph for the function. We get to be the one that determines what is what on there. I am going to move the graph so it's a little more in the center so I can see it a little better. And remember, I want certain points. I want to have these points that are grayed on there. That tells me these are important points on my graph. So I'm going to draw a U. I'm going to notice that it doesn't start at 0, 0. It's actually up here at a little past 1. And then it goes down, and then it comes up to here. So these are the points I'm going to be writing in, and that's the graph shape that I'm going to be pretty much graphing here. So again, he didn't start at 0, 0. He kind of started up here at this weird 1. And then he goes down and dives down deep, and then he kind of resurfaces at this point. So that's just extra stuff that we don't need either. All right. So his dive down, this top point, was at 1.0025. This point here, where he finally hits the water, was actually at 0.42786, I believe, comma 0. This point down here, that is my minimum. That's how far he goes down. So it was at 4.2, and then the y value was at, I believe, 5. I'll put 5 there, and then the x up here, where he resurfaces, is at 9.37. These are really big, long numbers, but they're just copying off Desmos. I'm doing this so that I don't have to keep jumping back and forth. So those were the important points off Desmos, and now I'm going to start answering these questions. So each of these are going to matter to me. So how high is the platform from the water? So this is how high he started. That's his platform where he's diving off the guy. All right, he's going to go in from here. So he's up at 1.0025. So I'm going to come over here. That's the y value. And the y value is done in feet, so I make sure I put feet next to it. All right. How deep is the dive that you make? Well, deep, that is how far down you go. That is, again, a depth question. So if I look at this, he dives down. The deepest he's going to go is to this point, and his y value is 5. So he's going to go down 5 feet. The next question asks us, how long? Well, how long something takes is time. So how long does it take to reach the deepest part? Well, again, this is the deepest he goes down. That was the minimum. This was the time it took him. So that must be 4.9, and we go minutes. So it'll take him 4.9 minutes just to hit the 5 feet mark. So he's going really slow. And then when will you hit the water from your initial dive? So again, that's a time question because it is a when question. So we're talking about when we'll hit it. So if I look here, this is where he first hits the water. This is where my water is. So I look at my, or sorry, went a little too far. I look at my X value. I don't care about my Y value. So that's that very first number. And I'm going to copy that one down. So that's at 0.42786. And I put my minutes. When, another time when will you resurface or come back up? So here's he going down and I resurface at this 9. So I'll go ahead and put that one, 9.37214 minutes. And then the last part asks for the practical range. Now remember, range goes back to the y. So how far up and how far down do we go? So we're going to go range, dot, dot. And in this case, which we get really used to putting 0, we're actually not going to put 0. That should have been negative because we're down -5. So -5 is the lowest it goes. And we get our little inequality signs. This is dt for our y. And then the highest it goes is all the way up here to the top of that platform. So just be careful if you're doing the positives. It kind of feels weird when you're doing the positive quadratics, you have a minimum. So he's going to actually be at the bottom, you're not going to start at 0. So there's the first one. Let's jump to 3. So a dirt bike launches off a ramp that is 8 feet tall. Its upward velocity of the dirt bike is 20 feet per second. The following function models the height of the dirt bike after t seconds. So the important part is this equation. So I'm going to turn around here. This is the equation that we're going to use. Again, this is our y. That's really our x, and it really comes down to it. And it's going to be a bike that launches. I can see it's negative, so I'm going to want my u to kind of head down like that. So again, I can start kind of getting my rough sketch, my x and y, nothing fancy. I can turn around and say this is ht right now, and this will be t. And then the ht represents the height in feet, so I know this is going to be how high my bike is. Height, and I want to make sure I put feet so that I know what unit measurements I'm going to be using the whole time. And then the other one, the t, is after t seconds, so that must be time again, and he's going to represent seconds. All right, so now let's go ahead and get this equation into decimals. So let's go ahead and clear off. I'm going to go back to home. So I have it starting nice and fresh, typing in the equation, -16 x minus 0.625 squared plus 14.25. All right, I'm going to have to zoom out a little. We might have to play with our u a little bit here. And we can, if you want, we can kind of change this so it doesn't look so high up like that. I can go into my tool area and kind of look at here and say, okay, the x doesn't need to be going all the way out to 10, so we can make this a lot smaller. In fact, it's only going to -1 and a little past 2 on that side. So if you want, you can come here and say, you know what, let's just do -5 to 5. That'll spread it out a little bit, kind of stretch it a little bit. I definitely want to make sure I get my maximum, so I want to be careful about this. It goes up to 14, so 15 is a good amount. We'll just kind of leave it at this shape for right now. So here's where I'm starting. This is where the bike starts off the ramp or whatever, and then it comes down to here. So these are my important numbers. So it's starting at 0.8. We have 0.625 and 14.25. And then we have when he reaches the ground. So he's kind of either up high, he's either on a platform or something, mountain, whatever you want to call it, but the ground is further below him. So let's get those points on this graph. So this one looks like he starts here, shoots up, and then kind of goes down. Put a little dot there and a dot here, because those are important points. So again, he starts off at 8. This, our maximum point, is 0.625, and then this is 14.25. That's the maximum points. And then our intercept, where it's hitting the ground, was at 1.5. It's going to be this long decimal again. We're just going to copy it and then comma 0 because it's at the ground. So there's no height to it at that point. All right, so now let's start answering these questions. What is the maximum height the byte reaches? So our maximum height, that is a height, it's a y. So I go to my y value, that's the second number, and I say it's going to be 14.25 feet. So we're going to use that wonderful feet. How long until it reaches that height? Well, that's a time question, so that's an x question. So that's going to be at 0.625 seconds. Sorry, after how many seconds does the byte land? So now we're talking about landing, and we're talking about time. So it's still the x, but it's on this part when we land on the ground. So it's going to land at 1.56873 seconds. And those are the real practical big points. But this next one asks, how high will the dirt bike be after 1 second? So it's asking at 1 second, how high is this point right up here? So I'm going to go to decimals because I don't have that point, and I'm going to click on my graph, and I'm going to get that x value to equal 1. Notice I'm just moving. It's at 0.15. It's at 0.2. I'm kind of going a little faster. My maximum wasn't even at 1, so I drew my graph a little wrong on that first one. And I go through, oh, I saw that one. There he was. And it has 1, 12. So at 1 second, he's going to be at 12 feet. So we go back in here and we say, okay, well, looking at Desmos and playing with it, it ended up being 12 feet. And then the last question, domain, again, we use our D. The domain is, the variable is T, so we're going to use T as his number there. The lowest that it goes is 0, and the highest that it goes is, oh, I didn't leave myself enough room, is going to be that wonderful big long number. This is as far out as it gets. So 1.56873 seconds, basically. All right, so that is pretty much it for this unit. Good luck. Make sure you go back, finish that second one, and then check to make sure that you did it right.